In this problem, we have to take the derivative with respect to x of the sine of the tangent of x. And since we have a function within a function, we'll just have to use the chain rule. So the derivative of this expression here would just be the derivative of the outside, or this sine function. So that would be the cosine, and the inner function stays inside. And now we have to multiply by the derivative of this inner function. And the derivative of the tangent of x is simply the secant squared of x. Now it's easy to remember derivatives for sines and cosines, but if you ever forget the derivative of, say, the tangent or the secant or the cotangent, they're all fairly easy to rederive. So let's do that really quickly, just to show that the derivative of this is indeed this. So the tangent of x is really equal to the ratio of the sine of x divided by the cosine of x. So if we take the derivative of this entire thing, then we're really taking the derivative of this quotient here on the right side of this equality. And the derivative of a quotient in general, we use the quotient rule. So let's say we have two functions, p divided by q. And these are both functions of x. Then the derivative of this would just be the derivative of p multiplied by q plus the derivative of q multiplied by p, all divided by the function q squared. So let's just apply this to the quotient that we have. So the derivative of this expression here is equal to, we need the derivative of the numerator and multiplied by the denominator. So that would be the cosine of x multiplied by the cosine of x minus, now we need the derivative of the denominator. So the derivative of this is just minus the sine of x, and this is multiplied by the function and the numerator, so times sine of x, and this is all divided by the function and the denominator, this cosine of x squared. So cosine squared of x. Now we just have to simplify this. Cosine times cosine we can rewrite as the cosine squared of x. Minus minus becomes positive, and we have sine of x times sine of x. So plus sine squared of x, all divided by the cosine of x squared. And the cosine squared of x plus the sine squared of x is simply equal to 1. So we can replace that with 1. We have 1 over the cosine squared of x. And it's also true that the secant of x is equal to 1 over the cosine of x. So we can rewrite this ratio as just the secant of x squared. And now that we've shown that the derivative of this tangent of x is really equal to the secant squared of x, then we know that the derivative of this entire expression is equal to this expression here.